Hello, and this is going to be a project we're going to do for, I guess it'll be 5C, even though it has nothing to do with trans-Neptunian objects, but it'll actually take a little time, get you guys more ready for this test that's coming up later this week, actually late this week, beginning of next. But anyway, this is going to be called the nesting solar system, and if I can actually get this thing to move, actually maybe better off being the nesting planets. We're not going to talk about the sun. We're not going to talk about the moon. We're not going to talk about cis-Jovian, trans-Neptunian, comets, cupids, Donners, or Blitzens, or even asteroids. But we're going to talk about basically the 9 planets, and yes, we are going to include Pluto. What is a nesting doll? This is a nesting doll. They usually were made in Russia, and they would take pieces of wood and they would actually carve them out so we could put one inside of the other. One very seasonal one, since we're getting close to Christmas, would be Santa nesting dolls. And you could actually, the way it actually works is we put the small one inside and then we put the top of the next one on, and it actually looks sort of like this. And I think there's actually a limit of 9 or 10 nesting dolls that we can make at any one time because of the size of the wood. But I've actually seen some of these things 5 and 6 feet tall. So I guess the taller the outside, the thicker the wall, and you still have a limitation to how many of these you can make. So one of the things we're going to do is we're going to try to realistically color these planets, at least the big ones, because we're going to have a tough time making a scale model of Jupiter and trying to fit anybody on the top row inside of it because of the massive size of the Jovian or the gas giants, and you guys know that already. We're talking about 12,000 kilometers versus 140 plus kilometers. 140,000 plus kilometers. So the scale, it's going to be pretty tough to do some of these, but we're going to give it a good old college try. So what you're going to do is you're going to design the size of the objects first, and then you're going to color them based on that. And I will show you a picture of a couple of kids from back in 2007 who did a phenomenal job, and really that's the last time I've done this object because I was out of earth science for quite a while, and if I don't have earth science, then I didn't have astronomy, and then now I'm back into astronomy, so we're going to try this again. So I'm going to give you this. This is actually out of the earth science reference tables, and my earth science kids would have had this in their notebook, but I'm going to give you this page plus maybe a couple others, which will actually deal with astronomy. Like I said before, we are not going to do the sun, but we are going to do Pluto, so I will have to have you guys write this down, and I'll show you this really quickly in class. This is basically for folks that will not be in class. And we're going to worry about the name, but we're not going to worry about mean distance. We're not going to worry about period of revolution, rotation, eccentricity. We're not going to worry about mass, density, or the number of moons. What we're going to pay attention to is the diameter. So we're going to start with the first one being Jupiter, the biggest one, and then we're going to scale everything based on Jupiter. We're just not going to say we're going to draw Saturn a little smaller. We're going to draw Mars a little smaller, and then Uranus a little smaller, and Earth a little smaller, and Neptune a little smaller, and Venus a little smaller, then Mercury a little smaller, and Pluto a little smaller. But we're going to draw them all with relative scale. So I'm going to ask you to take out a piece of white paper. I'll have that ready for you. First thing I'd like you to do is we're going to fold it, both hamburger and hot dog, very gently, and we're going to try to find the center of the paper. And in the center of the paper, we're going to draw a little itty bitty dot. And I'd actually like it to be big enough so that when you look for it, you can see it. But then when you actually just look at the whole piece of paper, maybe it's not very visible. Next thing you're going to do is you're going to take Jupiter's radius. You're going to divide it by 100, and really all you do there is you take the decimal place and you move it over to the left 2 places. And instead of 149,000, may only be a much smaller number. And I'm not going to give it to you because I want you to find it. Kids that are in class are going to show this to me before they go any farther. And what they're going to do is they're going to put it down here in the bottom right hand corner. That's where they're going to put their scale. And this is going to be the scale for everything that goes into this piece of paper. Next thing from there, I'd like you to draw a 100 millimeter long line, and that's 50 above to 50 below, and it'll look something like this. It'll take most of the piece of paper, and that's the idea, to draw Jupiter as big as we can, so when we actually start putting the other planets on there, we have a chance to actually see them. From the center of this, I'd like you to draw a 100 millimeter radius circle, and I'm going to give you a really funky looking compass, and we'll practice with it a little bit. But I'd like you to draw a 100 millimeter circle on this side or that side, and I don't really care if you're right-handed or left-handed. You may want to put it on one side, but it doesn't matter, because whatever you put the biggest one on one side, you're going to put the next biggest one on the other, and the next biggest one on the other, and vice versa. Okay, we're going to determine this scale using this scale size down here to actually find the size of the next 8 planets. And yes, we're going to do Pluto too. And then from the largest to the smallest, so we're going to put Jupiter on this side, we're going to put Saturn on this side, we're going to put Uranus, we're going to put Neptune, we're going to put Earth, we're going to put Venus, we're going to put Mars, we're going to put Mercury, and we're going to put Pluto. Vice versa, just back and forth, and you from the largest to the smallest. If you put the largest here, you're going to put the next largest on this side. If you do your largest one on this side, it'll be the next smaller one on this side. And you're going to do that until you get all 9 circles, including the one we drew here for Jupiter, all 9 circles. And then I'd like you to realistically color or texture each of the models. So I don't want you to color Jupiter when you get it here, because you're going to have Uranus in here too, and just color the part of Jupiter that's still visible, and then once you get the next planet in here, color what's visible on the next one. So it probably is wise just to wait till the end. And again, I will show you 2 real good examples from seniors that I had in Earth Science from way back when. And if seniors could do it way back when, I imagine the juniors and seniors that are in class this year can do the same thing. Okay, and then the last thing you're going to do is you're going to mark each planet, not with their name, but with their accepted symbols, which you should know really well from here. Okay, so that's it. And again, this is for kids not in class, not so much for kids in class, because I will be showing this as well as a really quick picture of those 2 kids again way back when. All right, thank you. Bye.